Chapter 2 starts out with talking about quadratic functions. And last year in Algebra 2, you spent considerable amount of time talking about quadratic functions. So we're just going to recap the characteristics of quadratic functions and the different forms that we have, and then do some more advanced algebra techniques when dealing with these quadratics. So we have our three forms. And last year we called ax squared plus bx standard form. Our textbook now calls that general form. So the general form of a quadratic is ax squared plus bx plus c. That's not too bad. However, when you get over to what we would call vertex form, with our a, h, and k value, our textbook calls that standard form. So we have to kind of separate that from our last year. Last year's standard form was ax squared plus bx plus c. This year it's the a times x minus h squared plus k. And then intercept form, that luckily stayed the same for us. X minus p times x minus q. Key values, a, b, c for our general form, a, h, and k for standard form, and the intercept were a, p, and q. A does the same thing in all three of these forms. That a value will be the same thing, which means if we have the a value in one form and we convert it to another form, the a value will be the same. A will always tell you if we open up or open down. If we open down, we have a maximum, and if we open up, there's a minimum. Now, how do we find the axis of symmetry, which is also the x-coordinate of the vertex? For general form, we do negative b over 2a, so you will need to know that. When we have standard form, it is just the h value, the number inside our parenthesis, and for intercept form, we add the two x-intercepts and divide by 2, and that will get us the x-coordinate. For finding the y-coordinate of the vertex, we substitute the value when we have intercept form and when we have the general form. And lucky for us, if it's the standard form one, it's just the k value in our function. Y-intercept. The standard form is nice because that c value, the number with no x to it, is our y-intercept. And then for standard form and intercept form, we have to plug in 0 for x and then solve for y. That will get us our y-intercept. And then how do you find the x-intercepts? And this is probably the more important one than as opposed to the y-intercept. For intercept form, finding the x-intercepts are easy. It's just the p and q value, so the opposite of what we see in our parentheses. For standard form, we set it equal to 0 and solve. And because standard form has the x minus h squared part to it, what we can do is get that parenthesis by itself, and then we can take the square root of both sides, undoing or using the square root method, square rooting both sides. So standard form isn't that difficult to get the x-intercepts from. In the general form, that's where it gets to be more complicated. We set the function equal to 0 and solve for x. Well, solving for x, you have all these different methods. You could factor, that's the one we want to check for first. We always want to check to see, can we factor this? Because that's easier to do. If we can't factor it, then you have other methods. Completing the square might be more efficient, and we'll talk about problems where that will be helpful. And then quadratic formula, that one works for anything. So if you're struggling with factoring and you're struggling with completing the square, then you may just want to go right to quadratic formula and say, I will always use quadratic formula. The downside of that is that the quadratic formula is time consuming. So if you're always doing that, even for ones that are easily factorable, you may not have enough time to answer all the questions if you're always setting up the quadratic formula. So this chart is something you need to be comfortable with, recognizing our three forms of quadratics and how to get the key points or the key characteristics from each form. All right, so example number 1, we're going to describe the graph of the function and identify the vertex. So for this one, what I'm going to do first is rewrite this with the x squared in front, so equals negative x squared plus 25. Because from here, you could do two things. You could say, well, this is in vertex form, it's just we don't have parentheses, so the x-coordinate of the vertex is 0, and the y-coordinate would be 25. But if that doesn't help, if that doesn't work for you, remember you can always do x equals negative b over 2a, because this is also in general form. Our b value is 0 because we don't have an x to the first power. So 0 over 2 times negative 1 is 0. So the x-coordinate of the vertex is 0. And then if we plug that back in, negative 0 squared plus 25, we get 25. So our vertex is at 0, 25. Now when we describe this quadratic, we're going to do our RST, R. We do have a reflection over x-axis. And something I want us to add to this now, because we really need to understand, okay, if it has a reflection over the x-axis, I want you to understand that it opens down. It opens down if it's a reflection over the x-axis. Shrink or stretch, there is none. T, we are just up 25. Letter B, well, the vertex is the easiest in this one. It's 6, 3. And then we can say reflection. There is no reflection, which means that we're opened. It opens up. Shrink or stretch, none. And then translation, we are right 6 and up 3. So vertex form is very easy to get our RST from, and the vertex. Letter C. We have 2x squared minus 10x minus 5. This is our general form. So to get the x coordinate of the vertex is negative b over 2a. So negative 10 over 2 times 2, that gives us 10 over 4, which reduces to 5 over 2. So that is the x coordinate of the vertex. And then we have to plug that back in to get the y coordinate. All right, then if we simplify that, it's 2 times 25 over 4 minus 50 over 2 minus, I'm going to change this 5 to 10 over 2 because I see that my denominators are all going to be 2. All right, then this equals 2 times 25 over 4 reduces to 25 over 2 minus 50 over 2 minus 10 over 2, and that will give me negative 35 over 2. And if you want to make that a decimal, you can. So that means our vertex is 5 over 2, 5 halves, comma, negative 35 over 2. And then describing it, there is no reflection, so it opens up. Opens up. There is a vertical stretch. In translation, we are right 5 halves and down negative 35 halves. And eventually we're going to get to the point where we don't need to do all of RST. You can just describe, oh, this is a vertex and it opens up. And that's kind of what we do for our rough sketches. We say, okay, our vertex is 6, 3, it opens up. So then you draw your parabola opening upwards. Example number 2, we're still going to describe the graph of the quadratic function, and this one we're just going to do whether it opens up or opens downward. We're not going to do RST. I wanted to do that for the previous ones just to kind of transition us. We're going to identify the vertex like we did previously, and we're also going to identify x-intercepts. So remember, intercepts are points. So don't just say x equals 5. I would need to see 5, 0. So example A, we have x squared plus 10x plus 14. So we want to see if we can factor that. Are there two numbers that multiply to 14 but add to 10? No, there aren't. So we can't do that. So you could do quadratic formula, or you can do completing the square. Completing the square might be better for this one because our a value is 1 and b is even. So I'm going to do it that way. So x squared plus 10x plus 14 equals 0. When we complete the square, we get the c value, or the number without x, by itself. And then this is when we take that 10, 10 divided by 2 squared, which is 5 squared. So we do x squared plus 10x plus 25 equals negative 14 plus 25. The left side now factors to x plus 5 squared, and the other side gives us negative 14 plus 25 is positive 11. And then to solve that, we'll square root both sides. So we get x plus 5 equals plus or minus the square root of 11. And then when we subtract 5 from both sides, we get x equals negative 5 plus or minus the square root of 11, which means our x-intercepts are going to be negative 5 plus the square root of 11, 0, and negative 5 minus the square root of 11, 0. Now for the vertex, this part right here, I'm going to rewrite that down. X plus 5 squared equals 11. If we subtract 11 from both sides, we get x plus 5 squared minus 11 equals 0. This is now vertex form. We have our h, negative 5, and our k value, negative 11. So our vertex is negative 5, negative 11. So that is another advantage of completing the square, is that you can also get the vertex form very easily from that. So we have our 2x-intercepts and we have our vertex. Letter B, we have negative 4x squared plus 24x minus 41. This one, I wouldn't do completing the square because our a value isn't 1, and we could divide everything by 4, but negative 41 isn't divisible by 4, so that's going to give us a fraction. So this one, it might be better just to do the quadratic formula. But let's find the vertex first. So x equals negative b over 2 times a, and that gives us positive 3 for the x coordinate of the vertex. So now when we substitute that back in, f of 3 is equal to negative 4 times 3 squared plus 24 times 3 minus 41, and that gives us negative 5. So our vertex is 3, negative 5. Now let's do the x-intercepts. Quadratic formula, x equals negative b plus or minus square root b squared minus 4ac divided by 2a. So x equals negative 24 plus or minus the square root of 24 squared minus 4 times a, which is negative 4, times c, which is negative 41. So then we're going to type in all over 2 times negative 4. Using our calculator, if we type in the stuff underneath the square root, which is called the discriminant, 24 squared. Notice I'm not typing in the square root part. Whoops. Times negative 41. Okay. I get negative 80. So we get the square root of negative 80 over negative 8. Now, before we go any further, we know that this will give us an imaginary number because the square root of a negative number is not real. That means there are no x-intercepts. So no x-intercepts. All right, this last one, x squared, negative x squared plus 6x minus 8. So x is a symmetry, or the x-coordinate in the vertex, negative 6 over 2 times negative 1. That's positive 3. And then f of positive 3 is going to be negative times 3 squared plus 6 times 3 minus 8. Be careful right here. You do 3 squared first and then make it negative. So you actually get, negative 9 plus 18 minus 8, which is positive 1. So our vertex is 3, 1. Now for the x-intercepts, we're going to set this equal to 0. And I like having my x to the first power, my x squared, to be positive. So we're going to divide both sides by negative 1. When we divide both sides by negative 1, we get positive x squared minus 6x plus 8 equals 0, because 0 divided by negative 1 is still 0. And then two numbers that multiply to positive 8 but add to negative 6, we can factor that to x minus 4 and x plus 2, which means our solutions are 4 and 2. So then our x-intercepts are 4, 0 and 2, 0. So I purposely did these problems the way I did because I did one completing the square to find the zeros, I did one quadratic formula for finding the zeros, and I did one factoring to find the zeros. Like I said, you could have used quadratic formula for all of these, but I just wanted to expose you to each method. Right, so on the next page, for standard form, f of x equals ax minus h squared plus k of the equation given the vertex and a point on the parabola. So what we'll do with these is we'll plug in or substitute in the x-coordinate in the vertex for h, the y-coordinate in the vertex for k, the x-coordinate for x, and then the y-coordinate of the point for f of x. And you can see the only thing that isn't highlighted, only variable that isn't highlighted, is a. So then we'll be able to solve for a. So now we're going to substitute in 3 equals a times x, but x is 2, minus the h-coordinate 4 squared plus negative 1 is our k value. So then we get 3 equals a times negative 2 squared minus 1. I'm going to add 1 to both sides and do negative 2 squared. So 4 equals 4a. Divide both sides by 4, a equals 1. So then we rewrite our function with our a value of 1 and x minus 4 squared minus 1, because we plugged our vertex back in with our a value, and x and f of x, or y, stay x and f of x. And then letter B, we have our h, k, x, and y, or in this case, f of x. So 2 is equal to a, then we have 0 minus h, which is 2 squared, plus our k value, 3. So 2 equals a times negative 2 squared plus 3. And just like with the last problem, we'll subtract 3 from both sides. We get negative 1 equals 4a, because negative 2 squared is 4. And we divide both sides by 4, negative 1/4 is equal to a. So then when we write our equation, f of x is equal to negative 1/4 times x minus the h value, which was 2 squared, plus our k value of 3. So this would be our function. Oh, this one has fractions. It's okay though. We can still do this one. Okay, we have our h and k, x, and y. So negative 16 over 3 equals a times negative 7 over 2 minus negative 5 over 2 squared plus our k value, which is 0. We have minus and negative, so we're really adding. So negative 16 over 3 equals a times negative 7 over 2 plus 5 over 2 is negative 2 over 2 squared plus 0. 2 over 2 is just 1, so negative 16 over 3 equals a times negative 1 squared plus 0. Negative 1 squared is just 1. So negative 16 over 3 equals 1a, or just a, and plus 0 doesn't change anything. So our a value is negative 16 over 3. So f of x equals negative 16 over 3 times x plus 5 over 2 squared. And since our k value is 0, we don't need to write plus 0 for the y-coordinate of our vertex. Right, then our last problem, we're going to be also using the graphing calculator to verify. It says use a graphing utility to graph the quadratic function and find the x-intercepts, then find the x-intercepts algebraically. Remember, that's when we do the second trace and select 0. So for this one, we'll do the algebra first for both of these and then go to the graphing calculator. So algebraically, 0 equals negative 2x squared plus 10x. We can factor out a negative 2x, and we're left with x minus 5. And I can assume that you would know that your zeros are x equals 0 and x equals positive 5. And if you wanted to verify using the graphing calculator, you could. Notice that I just wrote down the zeros, but our intercepts are 0, 0, and 5, 0. Now letter B, 0 equals 7 over 10 times x squared plus 12x minus 24. Well, here's the thing. If we multiply both sides by 10 over 7, the left side is still going to be 0. 10 over 7 times 0 is just 0. So we get x squared plus 12x minus 24 because the 7 over 10 and 10 over 7 cancel. Now, can we solve this by factoring? Are there two numbers that multiply to negative 24 but add to positive 12? No, there are not. So I'm going to solve this by completing the square. I'm going to add 24 to both sides, so we get 24 equals x squared plus 12x. Then we take that 12 and we do the completing the square part. 12 over 2 squared equals 6 squared, which is 36. So 24 plus 36 equals x squared plus 12x plus 36. That gives us 60 equals x plus 6 squared when we factor this. And then we'll square root both sides. We get, and I'm going to rearrange this, x plus 6 equals plus or minus the square root of 60. X plus 6 equals plus or minus. We can split up square root of 60 to 4 times 15. Square root of 4 is 2. So 2 times the square root of 15, and then we'll subtract 6 from both sides. So x equals negative 6 plus or minus 2 times the square root of 15. So algebraically, we would have our intercepts negative 6, negative 6 plus 2 times the square root of 15, comma 0, and negative 6 minus 2 times the square root of 15, comma 0. So then on the graphing calculator, I'm going to type in that original function up here, alpha y equals 7 over 10 x squared plus 12x minus 24. So we only see one x-intercept, so I'm going to change my x-min to negative 20 and positive 20 so we can see more of it. All right, now we see both x-intercepts, both zeros. So we're going to do second trace 0. And I'm going to find the leftmost one first. So I'm going to go all the way over here. Hopefully I start seeing the cursor soon. Oh, there's a cursor. So I'm to the left of that 0, hit enter. Then to the right of that 0, hit enter. And we get negative 13.745. So we're going to round that up to 13.746. I'll use a different color. Negative 13.746, comma 0. And then we're going to find the other one as well. So second trace 0. Now I got to go to the left of my other x-intercept. And we know it's going to be positive, so there we go. There we go to the left. And we go to the right. And we get 1.746, comma 0. So we can use the graphing calculator as well for this problem. Letter A, I don't think we really need the graphing calculator because we got nice whole numbers. But for B, because we got that square root of 15 involved, we did need the calculator to kind of verify it. All right, so thanks for watching the video. Make sure to like it and subscribe.